or that you've got baselines so that you know what normal behavior is, that your workloads are being updated where that's appropriate, and that your resource configurations are in a compliant state. That might mean making sure that certain things are encrypted, for example. Make sure that you've got a business continuity and disaster recovery strategy, and test it. So as you start migrating workloads into the cloud, make sure that you actually test that if something goes wrong, you can recover from it. Then you know it works, but up until then it's all hypothetical. And then make sure that the appropriate tools and templates are used to deploy landing zones. That is, once you understand what your landing zone should look like, you build a template to make sure that they consistently look like that. What you don't want to do is you don't want to hope that someone's going through a checklist and they make sure that they actually get every item on the checklist. You can automate this so that no one makes that mistake. Azure Migrate is a collection of tools that allow you to assess and migrate your on-premises resources and move those resources to Azure. We can see on this particular page that we've got the Azure Migrate Blade open, and you can see here that you've got your migration goals section that lists servers, database, virtual desktop infrastructure, web applications, data box. Then you've got the option to manage your discovered items, and then you've got troubleshooting and support. And we'll do a little bit of a demo in this session. And later on, what we're going to do is we're going to actually have a lot more in-depth migration demonstrations in later sessions in this particular virtual training day learning path. So let's talk about the tools RAM it needs, this is how much disk it needs, it'll look at the performance, and then it'll make a recommendation, assuming that you're basically doing a movement of that workload into the cloud, of what the appropriate SKU of virtual machine in the cloud is. So Azure Migrate Server Migration is the next part of that. And what that'll do is it'll actually migrate those VMware VMs, the physical servers, other virtualized machines, and public cloud virtual machines. So the next tool we'll talk about is a data migration assistant. And the point of the data migration assistant is, instead of just looking at servers like the first tools did, is that you're going to assess your on-premises databases for their suitability to migrate to Azure. So using the data migration assistant, you can find problems that might block your database migration. It'll also go and look at your SQL Server databases on-prem and figure out which features you might be utilizing that would actually cause a block because they're unsupported in Azure, and make suggestions about the right path for database migration. So it'll look at it and it'll go, oh, okay, you can go to Azure SQL on this, which is, platform as a service. Or it might be you can go to managed SQL. Or it might be that you need to run SQL in your own VM if you want to go and do it that way. Then you've got the Azure Database Migration Service. So you do your assessment first, of course, and then you actually, once you've figured out your assessment, you move on to the next stage. So the Azure Database Migration Service will allow you to migrate on-premises databases to Azure. So you can migrate to Azure SQL, Azure SQL Managed Instance, or SQL in an IaaS VM. And in a later session in this learning path, you will learn all about those different options, what they mean, why you choose one over the other. Then you've got Moviri. What this tool does is it allows you to assess servers, and it'll provide you with performance-based right sizing, cost planning, and dependency analysis. You've got the Web App Migration Assistant. This allows you to assess on-prem web apps and migrate them to Azure. It allows you to migrate .NET and PHP web apps to Azure. And then you've got Azure Databox. And the whole point of Azure Databox is if you have a fantastic amount of data that you need to move into the cloud, rather than trying to upload it, even over an express route connection, which might take some time if you're looking at a couple of terabytes, well, you can move your large amount of data offline to Azure by basically getting this box, you plug it in, you move your data across, it's all encrypted, and then it gets shipped off to an Azure data center, gets plugged in there. If you've got a nice big high bandwidth cable, you can move a lot of data over short distances a lot quicker than you can move it over a standard internet connection where it might be prohibitively expensive to move terabytes of data over your organization's business connection, and it might simply take too long as well. So what I'm going to do now is I'm going to show you how the database migration assessment actually works. And we're going to do this against the world famous AdventureWorks sample database running on an on-prem virtual machine running SQL Server. So let's get into the demo. So we start here in the Azure console and I type in Azure Migrate. I click in on Azure Migrate. And we can see here that we've got a variety of options that we can select from. The option I'm interested in is SQL and other instances. And what I select is assess and migrate databases. So it says here, getting started, first thing I need to do is create a project. And a project's like a container to hold whatever Azure Migrate project you're going to do. So you might start off with an assessment and then perform a migration, and all of that would be in the same project. So here I've got my subscription. I provide a resource group to contain this particular project. Now the resources themselves do not have to sit within this resource group that I'm migrating. This is simply to hold the migration project. I give the project a name. In this case, Tailwind Traders, AdventureWorks. And I've got my geography, again, where I want this to be stored. I click Create. It initializes the deployment's submitted. The deployment's in progress. And the deployment's succeeded. So I've got my brand new data Azure Migrate Database Assessment project. Okay, so what it gives me the option of doing here is downloading the data migration assessment tool and then performing an assessment once I've downloaded and installed that tool. So I select that item, download the data migration assessment. I'm going to open it up in a new tab. I'm cheating a little bit because I am running this browser on my SQL Server instance. In the real world, what you'd do is you'd download this to a shared folder and then you'd bring it across to your SQL Server instance. You would try to avoid directly accessing the internet on your SQL Server instance because that's not really great security practice. So here we can see we've downloaded it. I open up my downloads folder. I open up the Data Migration Assistant and I run through the wizard. So the first thing it does is ask me to agree to the license agreement, the privacy statement. It installs the Data Migration Assistant. I get a user account control dialog box. There's nothing particularly exciting here. So what I do is I click Finish. And then I close up my windows and we can see on the desktop I've got the Microsoft Data Migration Assistant. So I open that up. What we do is we start by creating a new project. Now, we've got two types of project type, and you're going to see this done in far more detail in a later session in this learning path. Here, what I want to do is I want to do an assessment. I want to give it a name. Now, this does not have to match my Azure Migrate project name. It's probably a good idea at least that they're similar though, because at some stage you're going to be uploading data from this assessment into that project. So here I've called it Tailwind Traders AdventureWorks. My assessment type is going to be a database engine. My source server type is going to be SQL Server. And then I specify my target server type. That is, what do I want to migrate this on-prem server into? So in this case, I've just said Azure SQL database. So I create. So what this report is giving me the option of doing is checking my database compatibility. Is my on-prem database going to be compatible with Azure SQL? Is there going to be appropriate feature parity? And that will tell me if there's feature parity between my on-prem SQL instance and the Azure SQL instance. Now, it might be that I'm not using all of those features. So it might be that this flags something and says, hey, you don't have this feature in Azure SQL. And your response might be, doesn't worry me, I'm not using that. Or it might worry you because you are. So I click next. Here what I'm doing is I am connecting to my local SQL instance. But all you're really doing here is providing the credentials that allow the assessment to occur. So localhost, Windows authentication in this case, and I click connect and it connects through and it says, okay, on this thing, you've got AdventureWorks as your database. So I'm adding that to the assessment. Then I click start assessment and it performs an assessment by connecting to that local SQL instance, looking at AdventureWorks, assessing the SQL instance itself and the features that are there, and then looking at the database and performing a preliminary analysis of the database to see if there's anything in that database that might cause a problem. So here we see instantly that it turns around and says, look, Azure SQL does not support this type of encryption. So if you're using this type of encryption in your database, you're going to probably run into some issues in this migration. So I can click on compatibility issues. It then analyzes my database for compatibility issues. And it comes back and says, well, full text search has changed since SQL 2008. Now, in this case, we're running on SQL 2019 and it's a SQL 2019 sample database. So I'm pretty sure in this case we'll be absolutely particularly fine, but it has actually come back and looked at some indexes and said, well, you've got these full text indexes here, so make sure that you go and check. But in this case, I'm reasonably confident that given that this is a sample database for SQL 2019, it's going to be okay. So the next step is I've done this assessment and I can upload this assessment to Azure Migrate. And the benefit of doing that is that I can get all of this information now stored in Azure rather than stored on this local instance where I've actually performed the assessment. So I sign into the Azure account that's got permission to that project, or in this case, it's exactly the same account that was used to create that project. I sign in. I select my subscription that that account has access to. And I've got my Migrate project there and I click upload. And what it does is it's going to upload all of that assessment information from this on-premises server into that project container that's sitting in Azure. So what we do is we minimize that window and we can see that we've got our SS database instances and our databases that are ready for Azure SQL. And in a later session in this learning path, you're actually going to see how to perform that migration in a lot more detail. Okay, so another thing that you can think about in terms of planning and assessing your migration. You might want to containerize your existing applications. You can move them to a web app, or you might want to put them into a container. Now, the advantage of doing a container is you can containerize on-prem, and then when you're ready to move to the cloud, you can just move your containers to the cloud. Containers will run fine on-prem or in the cloud because the container itself contains all of the stuff that's needed to run that application. And you can run it on your workstation, you can run it on a server, you can run it in the cloud. And migrating an application that you've already containerized is a lot cheaper than migrating and running an IaaS VM because a container is much smaller. So if you can go and take an application that's running on a VM and containerize it before you try a cloud migration, that's going to be a lot cheaper than migrating the whole VM and then continuing to run the VM in the cloud. Now, you can containerize ASP.NET, MVC, and WCF apps so that it runs in a Windows container. So there's Windows containers and there's Linux containers. Linux containers are the ones that most people are used to, but if a lot of your apps are running on say, Internet Information Services, then obviously using Windows containers is one of the options that you should investigate in terms of your cloud migration journey. Now, once you've containerized the app, you can easily move it using a container registry to Azure Kubernetes services on Azure, or even if you want to go to that hybrid route where you're running Azure Stack HCI, you can move it to Azure Kubernetes services on Azure Stack HCI. So the next thing I want to get into is a set of cloud migration myths. And we do this at the start of this track on cloud migration because there's some things that people believe about cloud migration that are simply not true. So let's get into them. At a high level, these myths are that migrating to the cloud will always be cheaper, that you should move everything into the cloud, that if you just create a replica of your on-prem environment, that'll help you save money in the cloud, that the only business case that you have for migrating to the cloud is server costs, that for every business in the world, an operating expense model is better than a capital expense model, and that moving to the cloud is as simple as flipping a switch. Okay, so let's dig down into these a little further. First, the first myth, the cloud's always cheaper. Well, if you've got a really poorly architected cloud deployment, that can cost a lot more than a well-architected on-premises deployment. And that's for the following reasons. It might be that you simply have poor cloud governance. If you don't put in place controls over how the cloud is used, you're going to have problems. For example, if you don't have controls over who spins up VMs, you might end up with developers spinning up VMs that never get taken down. I've seen that in my own work life, where I've gone into organizations to look at their cloud costs and found that they've had a multitude of virtual machines running that no one knew who had deployed them, what they were there for, and it turned out that developers had just sort of left them running, and it was costing that organization, thousands of dollars each month. You might have misaligned system architectures. You might have VMs hosting application code that with a small amount of work could be executed using serverless functions, and that might be 1/100th the cost of running it in a VM. You might have process duplication. You might have redundancy where it's already provided by the cloud because you've simply taken a model that worked on-prem and then applied it to the cloud. You might have weird or unusual system configuration. For example, you might have custom physical hardware on a physically deployed server that can't be replicated in the cloud without great expense. And it might be that there are greater staffing costs. For example, you might have to go out and hire developers and IT operations personnel with cloud experience. And of course, there's a lot fewer people out there with cloud experience than there is with on-prem experience. And when there's less of something, it generally costs you a little bit more. Okay, so the next myth, everything should go into the cloud. Well, not everything should be in the cloud, and some things must remain on-prem, and this means that you need to use a hybrid cloud posture rather than an all-in cloud postures. So let's look at some reasons. There might be a blocker around compliance. There are many, many countries in the world with Azure data centers, and there's a lot more of them. There's 192 countries in the United Nations, and there's not 192 countries that have got Azure data centers. And some countries say, well, you can't put these specific types of workloads, it might be a health workload or it might be certain types of personal information, across a national border. And if you can't put it across a national border, you probably can't put it in the cloud. It might be that there's specific traffic patterns. Let's say that you've got applications that require extreme data volume transfers. There's many, for example, organizations that work with video where they've got to move terabytes of video around, and obviously storing it up in the cloud and working on it in the cloud isn't exactly the right way to go. Local storage is probably a lot better, and that might mean that those workloads shouldn't go in the cloud. Or your application might require architecting. You might have an application that only runs on specific hardware or only runs on a specific operating system, and that operating system simply is not supported in the cloud. So to get it into the cloud, you're going to need to rewrite the application in a way that it'll function in the cloud. And that might be a really expensive proposition. So you might put that in a too hard basket for the near term and look at lower hanging fruit in terms of migration in the shorter term. Next myth, Making a mirror of your on-prem environment will help you save money in the cloud. Okay, well, we all know, especially if we've got any operations experience, that not every on-prem deployment is using its hardware most efficiently. There's a lot of machines out there that are hardly touching their processors, that are hardly using all of the RAM that's been allocated and hardly using all of those storage. So if you just went and created virtual machines in the cloud that had exactly the same configuration as your on-prem systems, you might be actually spending far more than you need to. There are reports out there that suggest up to 30% of existing servers are comatose. That is, that they're sitting there in data centers, either as physically deployed or virtual machines, and they're not actually doing anything. So if you come up with a migration plan where you move everything automatically to the cloud without performing any assessment whatsoever of what the utilization looks like, well, you could end up paying for a lot of Azure resources that aren't giving your organization any benefit. Okay, the next myth, server costs drive business cases for cloud migration. Now, there's a lot more to calculating the cost benefit than just the sticker price of what your server hardware costs. One of the things that you've got to look at is how long is your hardware refresh cycle. Some organizations have very short hardware refresh cycles, but some organizations have very long hardware refresh cycles. I'm saying here 5 to 8 years, but I've seen longer than that. And organizations that have very long hardware refresh cycles aren't going to see the benefits of moving to the cloud all that quickly. Business losses caused by outages can exceed hardware and software costs. And it's very difficult to make a calculation as to how often you're going to have those hardware failures and how much they're going to cost. So when you're trying to balance that against what the saving is in the cloud, and you're saying, well, if we're in the cloud, we're not going to have those failures, and someone comes back to you and says, well, how much is that failure going to cost? And you go, well, actually, I don't really know, but I know that if it's bad, it's really, really bad. You're not really making your business case. Now, the other thing is real estate, facilities, and utilities costs represent a substantial proportion of on-premises cost, which means it's not just the cost of the server, but the cost of the whole environment and the life support system that exists around the server. And unless you've got some pretty good accountants, you probably don't really know what that figure is. And even though there are pricing calculators out there, they're often run by people like us who obviously have a vested interest in getting you into the cloud. So your business decision makers might go, well, of course the cloud providers would tell us that it costs so much to run things on-prem, but unless you've actually got data as to how much stuff costs, that becomes a bit difficult to include in your calculations. Another myth. You'll hear all the time people are talking about OPEX versus CAPEX. There are certain industries where operating expenditures are viewed negatively. For example, if a business views its capital assets as a driver for the valuation of the business, if you reduce your capital expense by not buying servers anymore, that could actually reduce the valuation of that business. Now, this is often encountered in retail scenarios, in certain areas of manufacturing and certain areas of the construction industry. So if you made the argument, we'll shift from OPEX to CAPEX, you might get, well, we don't want to do that because that makes our business worth less. Organisations that are seeking a capital influx may consider increasing in operating expenses as a negative outcome. They want to reduce their operating expenses, and for them, cap expenses, certainly sunk costs, are a lot better. And then you've got businesses that are focused heavily on improved sales margins. So they want to make sure that their sales margins are as good as possible. They want to reduce the cost of goods sold. And if they've got high OPEX, that obviously plays with that equation. So it's not always the case that OPEX is better than CAPEX. And the final myth I want to hit, moving to the cloud is as simple as flipping a switch. Look, this whole learning path is about what you need to think about when you're migrating to the cloud. Migrations are manually and technically intense. If it was easy to do, everybody would have already done it. It's difficult to accurately assess the amount of time required to migrate workloads. Often you don't know how long it's going to take to migrate until you do it. And that can cause problems because if you've got an overly aggressive schedule, well, you're probably not going to hit it. So think about the following. Think about your bandwidth limitations. Think about how long you need to actually spend testing the migration. Look at your migration timelines and build in some fat if you can. And you're always, again, you've got that problem when you're talking about the business. If you turn around and say, hey, this is going to take a long time, you're probably going to have a lot less enthusiasm. Everybody wants a simple solution, but you've done this long enough to know that the simple solution's not often the realistic one. And make sure that you address technical and cultural impediments. There might be people that simply don't want to change the way that they're doing things, or there might be people who simply do not have the skills to do what you need them to do. Now, ways of mitigating your timeline risks is to do the extensive research. Look at your technical constraints. Do as much research as possible. You are all aware of the saying, measure twice, cut once. Well, that goes measure 15 times before you perform a cloud migration. Also, figure out who your key stakeholders are and what their objections might be, and then deal with those objections. And don't paper over them. Make sure that you've got a proper response to those objections, because those people might know things that you don't. And what you don't want to have someone do after your cloud migration fails is turn around and say, I told you so. Anyway, in summary, a well-planned cloud migration will be much more successful than just making it up as you go along. Azure Migrate is a set of tools that are built into the Azure portal that allow you to assess the cloud suitability of workloads, including determining workload dependencies prior to migration, and it also helps you migrate those workloads to Azure. Rationalize your on-prem workloads prior to migrating them. That is, go through your on-prem environment and make sure that that's as efficient as possible and that you've got rid of all of those VMs and those server workloads that aren't doing anything and those applications that are no longer being used before you start the migration. Don't migrate an application only to find out that no one's used it after you've spent weeks making sure it does migrate properly. And then make sure your Azure environment is prepared for workloads by configuring and using Azure landing zones. Here's a set of additional resources where you can find out a whole lot more. Thank you very much for your attention. So in that session, we looked at planning and assessing your current on-premises infrastructure for migration into Azure. We're going to take a 10-minute break, and then we're going to get right into the next session, which is all about planning and assessing the migration of SQL Server workloads and applications to Azure. Look forward to seeing you then.
Hello there and welcome. My name is Victor Vargas. I'm the Azure Technical Trainer Manager for US Southeast and LATAM. And today I'm going to be sharing with you how to choose the right migration strategy for your SQL Server and applications migration. So get ready to learn and let's jump into the content right away. On this class, we're going to be learning how to choose the right migration strategy for SQL servers and other applications that you may have running. It's going to be a really good class because data is one of the most important factors to take in consideration when you're thinking about migrating. Some of the topics that we're going to be sharing during this session are going to be why to migrate to Azure. We're going to be learning a little bit about the Microsoft platform that we have, which Azure data services you have available for your migration, and also determining which is the best strategy to migrate. Something that you will learning on this class is that migrating your data is something quite simple and exists many ways that you can do it that can be better for whatever circumstances you are facing. So let's jump into and learn about why to select or to choose Azure as your public cloud to go when you are thinking about migrating your on-premise infrastructure. There are plenty of reasons why you should select Azure to your migrations. And on this slide, we can see some of those reasons that we can take in consideration. There is definitely an unparalleled innovation in the way that manage and the way that we protect data happens on the cloud. The experience that Microsoft developed with SQL Server in the past decades are allowing us to have different ways to offer better services related with data. You have the opportunity to have your Azure SQL databases you need it. You can plan to have infrastructure as a service as well. And there is plenty tools available for you to help you doing your migration, making the process more simple and allowing you to have better control of what is going on. Another really important point is the security that you can apply to your migration because running this on Azure is allowing you to take advantage of the security tools around Azure that are available to you, like the Azure Security Center, Azure Sentinel, or confidential computing. Confidential computing is quite interesting because mostly of the security encryptions around allow us to have certain level of encryption in the way the information is being sent from one point to another. But with confidential computing, you can also encrypt your data while the data is being processed. So you can have a more control and more security in certain data that are really key factors for your organization. And finally, there is always plenty offers that you can use in order to make your migration project appealing from the financial perspective. There is actual migration programs around that you can check to see how you can benefit from those, in where you may have access to different partners that are really experiment and doing migrations like this. You also have the opportunity to use the Azure hybrid benefits that pretty much allow you to use your on-premise licenses on the cloud. On that way, you don't have to pay double when you are doing a migration. And also, when you are doing this, you can extend the security updates for maybe some on premise platforms, some SQL that are not even running more security updates because of the versioning. But if you are moving that to the cloud, there is ways to extend that in the meantime that is happening. It's important to understand what is moving people to do migrations. And maybe this is one of the most interesting topics that we want to discuss. When we do migrations, there is plenty triggers that are moving the organizations to do that. Some of those triggers are going to be infrastructure oriented because are going to be the drivers for that. Things like a data center contract that is expiring, or maybe you are facing a software end of support, or you are happening to leave a quick acquisition by different organizations or units inside your company. Many of these triggers helps to start doing a migration because the business owners or the SLTs in your organizations are going to be looking forward to start that. And there is a great moment to start thinking, what do I want to do with my data? Another reason why some people is starting to migrate their infrastructure to the cloud are based on the applications that they have and how they want to modernize that. Because we need to be sure that we are taking consideration all the potential security threats that we have, that we are being in compliance in the way we manage our data, and that we are presenting innovation in our applications. Now more than ever that we live in a really virtual world in where collaboration is really important, allowing people to connect from whatever point in the planet to work in your company, it's important to take this in consideration. How I am enabling the opportunity to people to collaborate, but making sure that we are secure and making sure that we are in compliance. Why migrate data and applications to Azure? There is different reasons why we want to do this, and maybe some of those reasons are really well explained on this slide. First, let's talk about SQL. We have over 25 years working with this tool. These 2 decades of information, use, and constant feedback are helping us to build one of the most powerful databases in the planet, and now is available on the cloud as well. Also, you have the unmatched experience that we have of having a tool that is being used globally. There is plenty people taking advantage of what you can store, replicate, and secure on the cloud. You can also take advantage of the unlimited storage that you can have over there and how that can offer you a really high SLA of up to 99.95%. And depending of the kind of migration that you do and you select to execute, you can even improve that number. Also, the migration is seamless. It's really simple to do migrations now. We understand how important is data. Actually, artificial intelligence is not going to be possible if we don't have the right data in the right location, being shaped in the right way. And that's why we have plenty programs and toolings that you can use in order to make your migration a successful project. And finally, we have plenty offers that you can take advantage of. As I was talking in the previous slide, the fact that you can use the same license from your on-premise SQL to the cloud during the time that you are doing the migration is a great opportunity to save money. Also, you can find different ways to use and access your data that may simplify the way you have now and make more simple the innovation that you are going to be getting during this migration process. But what is data platform modernization? And this is important to take it in consideration when we are talking about migrating data, because we don't necessarily want to only take what we have on premise and move that to the cloud as it is. We have the opportunity to discover what is really going on in our organization, who is using our data in any particular database and why, and how can we, after doing the assessment for all the different pieces, plan the proper migration project that you have, and even take the opportunity to transform and to optimize what is happening with your applications in your data, and even take the time to fix any problem that you may know is happening in your current design and rethink that in the process of migrating. It's a great opportunity to start fresh in many ways. When we are thinking about migrating and taking in consideration those steps that I mentioned, that we have to discover what we have, that we need to do an assessment about what's the best way to go, that we have the opportunity to fix the things that are not looking good, or even to transform and to optimize, we get to know about these 7 R's in the process of the planning, in where you can decide to remain in where you are. Maybe certain applications are going to go to decommission really soon, and maybe migrating those to the clouds is not the best way to go. Maybe you want to stay where you are and just wait for the time to decommission comes. Some other options are going to be to do some rehosting. Maybe you can learn that you can put several databases together and use one hosting server for that. You can refactor what you have, and you can even do some coding changes in some of your applications. So maybe you can move from a traditional SQL Server database to start using Azure SQL managed instances or Azure SQL database. And you don't need to have a virtual machine to host your SQL database that you may have right now. You can re-architect the whole thing. You can see how to make the dots connect better for you. You can use the opportunity that you can find that maybe some data is going to be repetitive in different databases that you are consolidating. And then that is going to give you the opportunity to re-architect and to rebuild what you have. Other of the R's that we take in consideration is when you want to replace something. Maybe SQL Server is not going to be the next database for your application. Maybe you want to move to Cosmos DB, to MariaDB, to PostgreSQL, or any other database server that makes sense for your application, and where are you planning to go. And finally, during the migration plan, you may reconsider or you can flag in advance which applications and databases are going to be retired soon. And you can design based on that as well to take advantage of what is going on with those applications. So now let's go a little bit more deeper and learn about the Azure data services that we have available for your migration. There is many different ways that you can do it, and it's important to understand maybe the three basic concepts that we have about databases in Azure. The first option is the SQL Server on Azure virtual machines. This is considered infrastructure as a service. It's going to help you to do the development that you need in an easy way, in where you're going to be having a virtual machine as you probably have in your on-premise environment, and right there you're going to be running your SQL Server. It's going to be kind of the same that you have, and it's going to allow you to have full control, not only for the database, but also for the OS in where that database is running. Sometimes you want to keep that responsibility for yourself. Sometimes you're going to want to delegate that to the cloud provider. And that's why we have offerings also in platform as a service, in where we can use Azure SQL managed instances or Azure SQL databases as the way to go. Those two options are quite similar, are both considering platform as a service. There is a few differences that you need to be aware of that we're going to be discussing later on this class. SQL Server on Azure virtual machines is going to be your first option to think about when you are doing a migration. Azure virtual machines run on many different geographic regions around the world. They also offer a variety of machine sizes. The virtual machines image gallery allow you to create SQL Server VMs with the right version, edition, and operation systems. This makes virtual machines a good option for many different SQL Server workloads. Something that you want to take in consideration is that on SQL Server on virtual machines, you can use the automated patching to schedule and maintain windows for installing important Windows and SQL Server updates automatically. You can also use the automated backup, which regularly creates backups for your databases to blob storage. You can also manually use this technique. Azure also offers you an enterprise class backup solution for SQL Server running on Azure virtual machines. A fully managed backup solution is supports always on availability groups, long-term retentions, point-in-time recovery, and a central managed and monitoring tooling. For more information, learn about Azure Backup for SQL Server on Azure virtual machines. High availability. If you are required to have high availability in your configuration, take in mind to use SQL Server availability groups. These involve multiple instances of SQL Server on Azure virtual machines in a virtual network environment. You can configure your high availability solutions manually, or you can use templates in Azure Portal for automatic configuration. And finally, the performance. Azure virtual machines offer different machine sizes to meet the various workloads demands that you may have. SQL Server virtual machines also provides automatic storage configuration, which is optimized for your performance requirements. To learn more about this, you can query the internet for a storage configuration for SQL Server virtual machines. To fine-tune performance, see the performance best practices for SQL Server on Azure virtual machines. Now, Azure SQL Server on Azure virtual machines offer different deployment features that you can take in consideration. The primary migration methods are perform an on-premise backup using compressions and then manually copy the backup file into the Azure VM. You can perform a backup to the URL and then restore into the Azure VM from the URL. You can detach the data and logs files and copy them to the Azure Blob storage and then attach them to SQL Server in an Azure virtual machine from the URL. You can convert the on-premise physical machine to a Hyper-V VHD, upload it to Azure Blob Storage, and then deploy it as a new virtual machine using the uploaded VHD. Chip the hard drive using Windows Import Export services. Or you can have an always on availability group deployment on premise and use the Add Azure Replica wizard to create a replica in Azure Failover and point user to the Azure database instance. Or you can use SQL Server transactional replication to configure the Azure SQL Server instance as a subscriber, disable replication, and point user to the Azure database instance. As you can see, there is plenty options that what can be done when you are deciding to have the migration going. And that is going to affect the level of availability that you are looking to have. Many ways to do a successful migration. When you are deciding if you want to do your migration in an ES versus PaaS strategy, it's plenty topics that you need to take in consideration in order to make a smart choice. You need to start thinking on what is going to be your business continuity plan. How are you planning to manage the high availability for your applications when required? What is going to be the process to get the backups? Do you want to have that to be done manually or automatically? What is your long-term backup retention plan? Where do you need to have your data being replicated? How are you planning to scale your applications and the data use of the models that you have? The security. Are we really certain that the security model that you have in place are going to be protecting the data and allowing you to stay in compliance? What are the versions that you are managing? Are you looking to have a more easy to manage environment from the version perspective? How do you want to monitor your applications? And more important, how are you going to go to generate intelligence from the data that you have and you are moving to the cloud? Another option when we're talking about migrations to the cloud is to use an Azure SQL database instead. And this is going to be the first step when we are talking about PaaS or platform as a service. Because right here, you are not going to be responsible for the OS. You need to worry only about your database. The Azure SQL database is always running on the latest stable version of the SQL Server database engine and patches OS with a 99.99% of availability. And that's a lot. PaaS capabilities that are built into the Azure SQL database enable you to focus on the domain-specific database administration and optimization activities that are critical for your business. With Azure SQL database, you can create a highly available and high performance data storage layer that can use for the applications and for the solutions that you have in Azure. SQL database can be the right choice for a variety of modern cloud applications because it's enabled you to process both relationship data and non-relationship structures such as graphs, JSON files, spatials, and XML. Azure SQL Database Services tier is the different ways that you can consume your database services, and it's important to understand the difference between the three of those. Azure SQL databases offer three services tiers that are designed for different types of applications. The general purpose or standard service tier is designed for common workloads, is offered a budget-oriented balanced compute and storage options, and it's probably going to be the way to go for many of your applications. The business critical and premium services tier is designed for OLTP applications, online transaction processing, with high transaction rate and lowest latency from the EO perspective. It's offered the highest resiliency to failures by using several isolated replicas. And finally, the hyperscale service tier is designed for very large OLTP databases and the ability to auto-scale storage and scale computing fluidly. SQL database instances is the intelligent, scalable cloud database service that combines the broader SQL Server database engine compatibility with all the benefits of the fully managed and evergreen platform as a server. SQL Managed Instances has near to 100% compatibility with the latest SQL Server Enterprise Edition database engine, providing a native virtual network implementation that addresses common security concerns and a business model favorable for existing SQL Server customers. SQL managed instances allow existing SQL Server customers to live and shift their on premise applications to the cloud with minimal applications and database changes. At the same time, SQL managed instances preserves all the past capabilities, automatic patching and version updates, automated backups, high availability that drastically reduce management overhead and TCO. At the same way that you can consume your SQL database, you can do with the managed instances. These methods allow you to have the general purpose model or the business critical one that we talked before. Azure SQL Managed Instances with Business Critical tier is built for high performance databases and applications that require low I/O latency for 1-2 milliseconds in average, with up to 100K IOPS that can be achieved using fast load SSD that these tiers use to place database files. The Azure SQL Managed Instance Business Critical tier is a cluster of SQL Server databases engines with one primary read-write replication, one free of charge read-only replica, and two hiding replicas that ensure 99.99% of availability. You can use different migration methods to move your data between SQL Server, Azure SQL databases, and Azure SQL managed instances. Some methods are online and picking up all the changes that are made on the source while you are running the migration, while in offline methods, you can need to stop your workloads that is modifying data on the source while the migration is in progress. There is some differences between your Azure SQL database and your Azure SQL Managed Instance database that you may need to take in consideration. There are plenty things that they are really common between the two that you also need to take in consideration. Things that they share, the way that they manage the language feature, database features, as things like for example, the tuning for your database, changing trackings, the database collisions, the contained for databases, contained for users, data compressions, and stuff like that. Also, things related with security, like the application's role, the dynamics for the data maskings, and the role level security. And the way that the graph processing and the way that the JSON data is being processed, same that Open XML, Open JSON, and XML indexes. However, there are some differences as well. For example, the always on availability is not quite the same between Azure SQL Database and Azure SQL Managed Instances, in where for the first one, we can offer a 99.99 to 99.995% of availability. While for Azure SQL Managed Instance, it's going to be only 99.99. That extra 5 at the end of the 99.99 that the Azure SQL databases have represent an important difference for certain designs and infrastructures, and it's something that we want to take in consideration. Also, the backup command for Azure SQL databases is only system initiated. So it's the system who manage the backups for you. For Azure SQL managed instances, you, the user, can initiate the copy for the databases to Azure Blob Storage if you want to. Another difference is the credentials. For Azure SQL databases, you can manage the credential, but only for the database scoped credentials. For SQL managed instances, you can do it, but only through Azure Key Vaults or shared access signatures are supported. Another topic to take in consideration is the cross-database transactions. For Azure SQL databases, you don't have that available. But for Azure SQL managed instances, yes, within the instance, you can have many databases working together and making cross-instance queries between them. Azure manages your database and guarantee the high availability. Some features that might affect the high availability or can be used in past world have limited functionality in SQL databases and SQL managed instances. These features are described in more details in the documentations about Azure SQL databases and Azure SQL managed instances, and I invite you to go deeply and review those in order to have a full picture of the difference between the two path options for your data migration. Something important to take in consideration when you are doing your migration to the cloud is that not everything needs to necessarily goes to an Azure SQL database or an Azure SQL managed instance or SQL server running on an Azure virtual machine. You also have the options to use other databases based on the project that you have, the impact that you are having, expecting to have, and what is happening from the industry perspective for those. With MySQL, for example, which is an open source SQL relationship database that you can use to organize data in one or more tables in which data types may be related to each other, is vertically scalable, which means one ultimate machine will do the work for you. Is currently the most widely used of the four database systems that we are talking here. PostgreSQL, sometimes refers as Postgres, is also one open source SQL relationship database with an emphasis on extendability and standards compliance. It can handle JSON now too, but is generally better for structured data, vertical scaling, and to maintain in compliance things like e-commerce or financial transactions. Azure Database for MariaDB is a relationship database service based on the open source MariaDB service engine. It's a fully managed database as a service offering that can handle mission critical workloads with predictable performance and dynamics that allows scalability. All of this, what is showing us is how much options do we have and how many we can take in consideration when doing a data migration. Let's go a little bit deeper with Azure Database for PostgreSQL. As we said, it's a relationship database service in the Microsoft Cloud based on the PostgreSQL Community Edition, available under the GPLv2 license database engine. Some of the characteristics that you can guess with PostgreSQL is that it's going to help you to deliver a built-in high availability, a data protection using automatic backups and point-in-time restore to up to 35 days, automated maintenance for underlying hardware, operation system, and database engine to keep the service secure and up to date. Predictable performance using inclusive pay-as-you-go pricing, elastic scaling without seconds, enterprise-grade security, and industry-leading compliance to protect sensitive data at rest and in motion, monitoring and automatizing the simplified management and monitoring for large scalable deployments is an industry leading support experience. These capabilities require almost no administration and are all provided at not additional cost. They allow you to focus on rapid application development and accelerating your time to market rather than allocating precious time and resources to manage virtual machines and infrastructure. In addition, you can continue to develop your applications with the open source tools and platforms of your choice to deliver with the speed and efficiency your business demand, all without having to learn new skills. So at this point, we're talking a lot about what is possible to do from the theoretical perspective. Plenty information is being presented to you on these slides so far. But what better than a real example to see how can we do a migration, how can we do an assessment, how can we start creating artifacts in Azure that are going to help us with the migration. On this module today, we're going to be doing two demos. One is going to allow us to provision an SQL server on an Azure virtual machine. Is one of the first steps that the people takes when they are starting to migrate data or SQL databases to Azure, and we want to learn how to do that. Also, we're going to be learning how to set up the environment properly to do an assessment on a machine that maybe we don't know very well. Let's say that we have a machine on premise that we know has some data artifacts running on it, and we need to determine what to do with that and what is going to be the best way to go. So all of that is going to be happening on this demo. The first thing that I'm going to do then is to create a virtual machine on Azure that has SQL Server as a database of preference running over there. For that, I'm going to go to my browser right here, and I'm going to go and log in the portal azure.com. And I'm going to get into the account. I'm logging into. And then I have here my regular environment to do well, anything that I do on Azure. So let's start from scratch, right? Let's say that we're going here and we're going to create a new resource group. We want to have a new resource group that allow me to host all the different components that we are creating right here. We're going to be using my subscription right here, and we're going to be calling this as the SQL migration demo 01. Okay, this is one way to call it. We can put it right there. And I normally use Eastern US 2 is the region that I'm going to select right here. So this is going to create a space for me to host all my different components related with this migration. So now we have the place right here, and we want to go and add to this resource group a new SQL server on Azure Virtual Machine. For that, we're going to be provisioning an SQL Server 2007 on a Windows 2016. And we're going to be using a free SQL Server license for developers that we have available. So let's click on add, and let's say that we want to get an SQL Server 2017 on Windows Server 2016. You can see that you have plenty of options that you can combine based on your findings. For this demo, we're selecting this one right here, but you have other versionings available that you can work on as well. I'm going to select that one right there. I'm going to select the plan that I want. On this case, for the demo purpose, I'm going to be using this free SQL Server license that includes SQL Server 2017 developer on Windows Server 2016. That's what I have right there. We're gonna create on that, we need to put a name for this virtual machine. So let's call SQL 2017 in VM 2016. So we remember that, and I'm going to put it demo 01. Something like that is going to be good enough. You can select the region in where you want to go right there. We have already the image that we're going to be using for this, and we are going to be keeping the selected site that they have. As you know, right here, you have access to plenty types of machines that you can select based on the need that you have. For what we are good with this one right here, so no changes on that one. Now I'm gonna define what is gonna be my administration user and password. I'm gonna put it right here, username and the password for both. Okay, so you may need to take note of this one. I'm using SQL admin as the username that I want to create as an administrator for this machine, and I'm setting a password that is passing through the verification that is required. So now that I have this done, I'm gonna review and create, and this is gonna take a few minutes to create the machine for us that we're gonna be able to access quite soon. Before you can check what you are creating, important, always be sure that you are using the right subscription. If you have more than one, which resource group you are putting all your things together, and also the machine name is important. I'm gonna copy this and save it around my notes because this is gonna be useful later on. Okay, so that's good. Let's create this machine. All this is going to be creating the machine for you. You don't have to do any configuration for your SQL or for your Windows server. Everything is going to be built based on the image that was selected. Now, let's wait for the machine to get created. Now, our deployment is complete. The virtual machine was created, and we can go to the resource to see what we have right there. Here is the machine. We can connect through it and download the RDP file that we need for that. That is gonna prompt you with this connection request. And right there is gonna try to connect. On this case, I want to use a different account because I'm gonna be connecting to this machine using the credentials that we defined previously, in where we said that SQL admin is gonna be the user, and right here I took note of my password. It's gonna prompt you with this information notification right there, and then it's gonna connect for us. And we can see the machine right here that has everything we need in order to have a database running on it. It's a Azure virtual machine with Windows Server 2016, SQL Server 2017. And the machine is here. We're going to use it later on. I just want to show you that is a resource that you can access after was built, and you are going to be able to play with it and use it for your migration. I'm gonna disconnect from the machine for now, and now I want to start preparing ourselves to the migration that we are doing on the next demo. Something that is important to have when you are doing a migration to databases. On this case, that we're going to be simulating the migration from an on-premise virtual machine to an Azure virtual machine, is important to have a storage account that both servers can access in order to manage the backups. So for that, let's go back to our resource. We created a special resource for us today. We call it SQL Server Migration Demo 01. And right here, what we have so far is only the virtual machine that we just created and the different components that that machine has, including the public access that we have for this machine and the different disk and network that was created for the same. So let's add a storage account just to have it ready. We're going to go here and set a storage account. And this is going to allow us to create a brand new storage account for our migration project. I'm going to put it on the same resource group that we create the VM. We want to have it on the same region as well because it makes sense to us. And let's call SQL migration storage account 01 demo 01. Okay, so we have a valid name right there. We are going to create and review this resource. Okay, all good, nothing different to normal right there. And we click create in order to have this component built for us. Let's wait a few seconds because this one is not going to take long to get created. Now our deployment is complete. And again, if we decide to go to the resource, we can see that we have our storage account created. For the storage account, we want to go right here to the file service area. In the files shares right here, we want to create a new file share inside of this storage account. And this file share is going to be called share backup. And we're going to set in 200 gigs of space for this one, and we're going to create. So now we have a file share that is going to be used to have this share backup between the machines. Something interesting right here is that if you go to these three buttons right here and you click on connect, it's going to allow you to identify ways to test your connection. But something that we want is that we are going to be using a drive letter in both servers, the server that we are going to be having the on-premise database that we're going to be seeing in a moment, and the new SQL server database that we created on the Azure virtual machine. They both are going to be using a drive letter in order to access the file share. Let's say that we want to use the letter U in order to do that. Please do so and copy this copy that is this line right here that is doing the map server that we just more about what strategy are going some things that we do previous to our migration when we are discovering what the artifacts that we have related with data, when we are doing some assessments on that information that we just collected, and we do any sort of conversion that we need to do and design what to execute to later on do the migration as we want it. That's what we're looking to have. Because after the migration is done, we need to have something that is working in a cycle way in where you know that you are getting the opportunity to run your application properly and to keep optimizing what is going on with your data. About that, we have two ways to do the migration. One is going to be the offline migration that is represented on this graphic, in where pretty much what we're going to be doing is to stop using the application during the migration process. That's what we call an offline migration. The Azure Database Migration Services enable online and offline migrations from multiple database sources to Azure Data Platform, all with minimal downtime. The service uses the Microsoft Data Migration Assistant to generate assessments report, identify tasks that are performed by the database migration service. And offline migrations require shutting down the server at the start of the migration, which means downtime for the service. So if you decide to go offline, it's because you know that you can have your application not running or at least not hitting the database with requests or with updates during the time of the migration. An online migration uses a continuous synchronization of live data, allowing a cutover to the Azure replica database at any time. The online option is the better of the two if you need to minimize downtime for your workload. Your relationship database can be migrated to a number of different destinations in Azure. You can go to a single Azure SQL database instance. You can go to an Azure SQL database managed instance, to an SQL server on an Azure virtual machine, which is going to be part of the example that we're going to be running later on. We can do an Azure database for MySQL, for Postgres SQL, or for Azure Cosmos DB using an online migration as well. The high point for this kind of migration is yes, you can keep your application running during the time the migration is going. That is going to maybe affect a little bit the speed that this migration is going to be executed, because you need to manage that synchronization, but it's going to be a good way when you are talking about migrating high critical business applications. There is some database migrations information available for you. So please make sure that you take advantage of this. You can select any of the targets that you see right here in order to get more data if you visit the Azure Database Migration Guide, in where you can learn in detail how not only migrate SQL Server, but also how to migrate Oracle, DB2, MySQL, PostgreSDB, Mongo, Cassandra, MariaDB, even Access, SAP, and any other sort of Azure table storage that you want is going to be possible to migrate. And there is detailed step-by-step guidance that you can use. And we invite you to take a look on that. One of the things that we're going to be learning now in the demo is how do you do a Microsoft assessment, or how do you do an assessment using the Microsoft Assessment and Planning Toolkit. There is a particular tool that we're going to be learning right now that is going to allow you to get familiar with a server that maybe you don't need that well. Many times we get projects in where we have several servers that needs to be migrated with their data on it, and we don't know exactly which applications are there, what is the different compatibility that could happen. So it's important to have the ability to run an assessment, and that's what we're going to be learning on the next demo. We're going to be learning how to connect to a server that we are just getting access to run this assessment, and later on migrate that database to Azure. So let's go to the second part of our demo right now. As you may remember, we ended our previous demo session having a new resource group in where we are putting all our Azure artifacts together. This is just because we want to have some sort of order, so I'm doing it that way because I want to. You can separate this as in many resource groups that you want, making sure that you have the right connectivity between them, or you can have everything that you need for your project in one single resource group. Right now, we created a storage account that we're going to be using for the migration because, as I said, we need the two machines, the one that we just created and the one that we are going to be migrating to here, to have access to this storage account so they can share the backups that they created. And those backups are the ones used for their migration. Understanding that, now it's time to go and get familiar with the machine that we want to migrate. Let me introduce you to the London server. This server is running currently in one lab environment that we have. Actually, this is a fantastic example of virtualization that we have here in Microsoft. So this server is running on a non-connected environment to the virtual machine that I have right now on Azure. We need to make that possible to this one. And right here, we have an SQL database that we are going to be migrating. But we know that already because we're going to be doing this demo. What if you are not familiar with the server and you don't have all the details in order to understand what is going on this machine? Well, let's start with that. One of the things that you want to do on this machine is start looking for the tool that is going to allow you to do the migration. As I mentioned during the presentation, there is a tool called Microsoft Assessment and Planning Toolkit. And that's the one we want to look for to have on this machine. I don't have it yet because I'm doing a real example with you guys. So I'm going to look for it right here. I'm going to use this component that I have to pass text to this virtual machine. As I said, it's a non-connected environment. So I'm using the tooling right here to get it. And right here, if you put that on any browser or if you put it in any share drive that you want to bring to that machine, you can get the tooling from there. The tooling is going to be a few of components that you need to access. Right here, we have the Microsoft Assessment and Planning Toolkit. You want to download that and all the files related. Click Next. That is going to download for you all the components that you need in just a few seconds. It's a really quick and easy to install software for the server that is going to be migrated and is going to help us to do the assessment that we want. Once all the components are downloaded on your machine, you go ahead and just execute the map setup exe file that you just downloaded. You're going to click run on that and follow the wizard in order to get the installation done. We're going to accept the terms for the license agreement. We're going to keep the default installation path, and I'm going to set install. Now we will wait for it to get the installation done. Now, our Microsoft Assessment and Planning Toolkit is already installed on the machine. So let's click Finish on the wizard. And let's go and look for it so we can do an assessment. You type map, Microsoft Assessment and Planning Toolkit is going to appear for you right there. And right here, I do have a little piece of advice. Something important when you are running an assessment is to make sure that you have your firewall properly configured to allow you to do that. So in order to do so, there is this line of command that we can execute real quick in order to make sure that the firewall is not gonna impact us. This is the line that I'm gonna be running right now. I'm gonna tell the firewall to allow me to have the remote connection to it and make sure that that do not affect my assessment. So I'm gonna copy this. I'm gonna go to the machine that I'm working on. I'm gonna go to CMD. I'm gonna run this as an administrator. And being here, I'm gonna copy that text that I just showed you. There you go. You just run that line. And with that, you are going to make sure that the firewall is not going to give you any trouble for this assessment that we're going to be doing. Now we're going to be running the assessment. The first thing that we need to do is to create a database. So assessment. Assessment DB01. Okay. And I'm going to click OK on this. Now I have the Microsoft Assessment Tool and Planning Toolkit ready. You can use it for many things, and we are not going to be going in all the different details, but this is going to help you to do and to assess many different scenarios that you may need for a migration, including a database migration right there. And as you can see, you have the ways to recollect information, not only for SQL Server, but also for some other products around that you can select. Now, let's go and try to do our first assessment. I'm going to be using that database for sure, so that's good. Let's collect inventory information right here. So what we're going to be doing on this one is we want to do an assessment on this case for SQL Server details. We want to have that, and SQL Server as well is another option to add. On the discovery method, for this one, we are not going to be using Active Directory because this machine is not connected to my domain. So I don't really have credentials on this Active Directory right here. However, I do know which is the Windows network credential that I want to use. Sorry, it's not this one. Manually enter computer names and credentials. That is what we're going to be doing for this one right here. We want to go and create right here that account naming that I have. I was told which is the user and password for this machine right here. So we're going to be using that as the credentials to log in on the machine. So right here, account name is going to be administrator. And right here, we have the password that we want to be using. I'm going to save this. I'm going to click next. So we have the credentials, we have administrator. Right here, we need to specify the computer. And this is going to be localhost, or you can put the name of the machine. And right here, we need to specify the user and password. So we have it right there. We save this, we move forward. Now we are ready to run this assessment. We are telling, hey, I want you to help me out to do an inventory of scenarios with SQL Server database with details. It's telling you which is the protocol that is going to be using for connectivity, with machine is going to be getting connected, and then we are ready to run this assessment. We're going to click finish, and we're going to wait to the machine to do the assessment. Now we can see more information about it. We can see the database that we saw originally. Now we see that if we have more than one, you're going to be able to see on this pipe all the different options that you have. But now we're learning something additional. We're learning that we have just the database engine services, but we also are using integration services right here, analysis services and reporting services as part of what is running on the machine. Another thing that you have access when you run a detailed assessment is that you can access more information about what is going on and have access to these files right here. I'm going to be downloading that one so we can access the file and see what do we have there. This file is going to show you not only, in this case, I don't have an Office product running right here, but I can just close that up. And then we can see I have one machine, one SQL server on this machine. I can see more details about it. I can see the summary of the database and every of the different databases that we have, sizing that we have for logs, for the database, etc. We can see the instances that we have right there, properties that are important to manage, users and IDs and passwords that we have, no passwords, user IDs that we can have for that particular set of databases. So right here, you have a report that you can show to your management, to your operations team, or to the project in order to define what the next step is gonna be. Now we have all the data that we need about this database running on a machine that is not connected to us, but now we want to find a way to migrate it. At this point, for the class that we are taking, we learn about the different ways that we can do migrations. We learn about the PaaS solutions, the IaaS solutions. We created one virtual machine with Azure SQL running on it. And we also have access to one machine, London, that requires to be migrated. We downloaded and installed the migration assessment and planning toolkit, and we were able to identify all the details about the database. Those are the demos that we are going to be running on this chapter. In the next chapter, we're going to be doing the real migration from this London server to the SQL server that we just migrated. Learning this material is a big step towards becoming Microsoft certified. Microsoft has certification paths for many technical job roles, and it shows that you are keeping the pace with today's technical roles and requirements. Check out these related certifications and gain a new professional edge. So what about it? Until now, we learned how to create a new SQL server running in a virtual machine, and we also know how to do some assessments in machines that maybe we don't know really deep. So it's a good time to take a break, don't you think? Let's go for it, and let's resync in the next chapter of this class.
Welcome back from the break. Now it's time for Module 3, Active Directory Identity Migration. This is important for organizations already using Active Directory on Windows Server who want to migrate virtual machines or applications to Azure. You'll learn about the different architecture options available with Azure Active Directory and how an Azure Windows Server virtual machine can be domain joined. Let's get started. Welcome to Active Directory Identity Migration. My name is Sonia Cuff. I'm a Senior Cloud Advocate at Microsoft, and in this session you will learn how an organization can migrate their on-premises identity into the cloud. All sessions in this learning path use Tailwind Traders as our fictional company, and this company has a central office and branch offices spread across cities in multiple geographies. They use single ADDS forests, and branch offices are connected to one another using a basic hub and spoke network topology, with the head office being the hub, and occasionally directly configured VPN connections between specific branches. Even though the majority of their workloads will be migrated to the cloud over the next, say, 18 months, Tailwind Traders will continue to require an on-premises Active Directory for the foreseeable future. With any technology, it's important to start with the business requirements. And for Tailwind Traders, these include things like a number of the Windows Server VMs that they're migrating into Azure still need access to Active Directory domain services. Now, this could be for reasons outside of their control. They might be running third-party line of business applications, for example, that need Active Directory to be the identity provider for authentication. In fact, several of the applications that they have rely upon a custom Active Directory schema extension to function. And that's not supported natively inside Azure Active Directory. Several applications also need access to data stored in an Active Directory domain services partition. And some applications require group policies to be applied consistently across virtual machines in different application tiers. That's a pretty heavy list of technical requirements to make sure that the applications that they're using continue to function after a cloud migration. And because Tailwind Traders doesn't have time to refactor or replace all of these applications, they need to come up with technical solutions to these problems. Tailwind Traders will start by looking at Active Directory domain services on infrastructure as a service virtual machines. With this option, they would connect their on-premises networks to Azure using a VPN or ExpressRoute, and they would deploy their ADDS domain controllers as infrastructure as a service virtual machines on the Azure Virtual Network. Now, these could be configured as domain controllers in a separate site, or they could be configured as domain controllers in a subdomain of an on-premises forest. The good part is that ADDS supports custom group policy objects, schema extensions, and custom AD partitions. But the downside is that Tailwind Traders will continue to need to manage these virtual machines and pay for the running costs of these VMs. Like any domain controller, they're going to need to make sure that they are performing and available and patched for security updates. From an architecture perspective, it hangs together like this, where the on-premises network has a gateway connection through to Azure and has existing Active Directory servers. Then inside Azure, we're running Active Directory domain servers, our domain controllers, as virtual machines inside a separate subnet inside our Azure Virtual Network. This means that we can protect those servers by tightly configuring the settings in the network security group in terms of what traffic is allowed to connect to these servers. The Azure Gateway between the on-premises network and the Azure Virtual Network will handle the synchronization requests between the Active Directory servers that we have on-prem and the Active Directory servers that we have in the cloud. With an ADDS resource forest inside Azure, we're creating a separate Active Directory domain inside Azure that is trusted by the domains in your on-premises AD forest. So our forest contains our domains, and this architecture creates an ADDS forest in Azure that has a one-way outgoing trust relationship with an on-premises domain. In this example, the forest in Azure contains a domain that doesn't exist on premises. And then because of the trust relationship, the login made against the on-premises domains can be trusted for access to resources in the separate Azure domain. We choose this because it includes allowing us to maintain security separation for objects and identities held in the cloud and migrating individual domains from on-premises to the cloud. And it's similar to the previous option insofar as our on-premises network is connected to Azure using a VPN or ExpressRoute. Our ADDS domain controllers are spun up as virtual machines inside Azure on the Azure network, but here they're configured as a new forest. It also supports custom group policy objects, schema extensions, and custom AD partitions, but we do also have that downside of having to run and manage and update these infrastructure as a service virtual machines. From an architecture perspective, we have our on-premises environment with our gateway and our Active Directory servers, and we have our gateway connection over into Azure, into our Azure Virtual Network. And then for our Active Directory domain servers that are running as virtual machines protected by this network security group, they're configured to have a trust relationship back through to the domains in our on-premises Active Directory servers. You might think that perform a similar function in terms of holding credentials and providing that authorization and the authentication process. But Microsoft handles the infrastructure in the background. You don't have to worry about the status of those domain controllers, for example, or whether they're replicating from one site to another globally. That's all handled by Microsoft, and you don't get visibility of that underlying service that we're providing. Within Azure Active Directory, you have an Azure Active Directory tenant, and this is your own dedicated and trusted instance of Azure AD that represents your organization. When an organization first creates this AAD tenant, it will be labeled as whatever.onmicrosoft.com, related to the email address that they use to set up this initial AD tenant registration. Now that can't be changed. It will be kept in the background for admin purposes, but you can add and verify your own custom domain. And that means that people can log in with a user account that is familiar to them, like their email address, for example. That custom domain has got to be a domain name that's already registered with a domain name registrar, and in the setup process of adding that customer domain to the tenancy, you have to verify it by going in and adding a TXT record into the DNS settings with a specific number in it. So you need to have the ability to do that to verify that you own that custom domain. It's worth remembering that you don't get an Azure Active Directory account just because you've created an Azure account. For organizations that are using other Microsoft Cloud services as a service, like Microsoft 365, for example, that is underpinned by Azure Active Directory as the identity platform for the user accounts for that service too. So if your organization has started off with Microsoft 365, you already have an Azure Active Directory tenant. The main differences for Azure Active Directory versus our on-prem AD is you don't have any of those domain controllers to manage or worry about replication between different cloud regions of those identities. But another important difference is that Azure Active Directory does not have any organizational units. So you can't build up a hierarchy inside this identity platform. It's a flat structure of users. Tailwind traders can use Azure AD Connect to synchronize identities between their Active Directory on-prem on Windows Server and their Microsoft Azure Active Directory. When those identities are synchronized to the cloud, it means that they can use things like single sign-on, multi-factor authentication, and self-service password reset. So all of those capabilities and any of the changes that happen to your on-prem Active Directory are looked at by the sync engine and managed. Instead, you can look at using pass-through request from the cloud system back through to the on-prem Active Directory. It gives us the same advanced features with Smart Lockout additional access, but we don't have to try zone a special DMZ area or any inbound firewall requirements. Remember, we couldn't do that before we domain joined the server. It's going to step us through the login process.